Hello, my name is Anna Helford, and I am the Idaho State Botanist for the United States Bureau of Land Management, a federal land management agency responsible for stewardship of over 991 million hectares of public land in the U.S. I would first like to acknowledge that I'm giving this presentation from the ancestral lands of the Shoshone-Paiute and Shoshone-Bannock people here in Boise, and to thank them for their stewardship and traditional ecological knowledge of these lands. This presentation will link concepts and practices outlined in the U.S. National Seed Strategy and the 2020 International Network for Seed-Based Restoration International Native Seed Standards to reiterate the important and universal steps in securing, increasing, and distributing source-identified native seed to improve the success and scale of restoration projects. This national strategy and the upcoming second edition will continue to provide an important framework for federal agencies such as the Bureau of Land Management. Germane to this presentation in particular is Goal 1, identify seed needs and ensure the reliable availability of genetically appropriate seed. This goal will be discussed by providing some U.S. regional and international examples and tools. At the global scale, not only a seed strategy is important, but native seed standards are the critical nexus to address these uniform issues. The use of native seeds is critical to the recovery of functional ecosystems following degradation. The native seed supply chain is not ready to provide enough seed to fill the rising demand. Local and national native seed markets still often lack the guidelines and framework necessary to support sustainable development to benefit ecological restoration. And there's not a clear and shared definition of what constitutes native seeds for ecological restoration. The International Network for Seed-Based Restoration, in collaboration with native seed scientists, seed producers, and restoration practitioners, has developed the first international standards to guide seed use and restoration globally. The standards are designed to be accessible and practical for all those involved in the collection, production, and use of native seeds, and are relevant at all levels, from community programs to large-scale commercial native seed enterprises. With the National U.S. Native Seed Strategy and the International Native Seed Standards as important foundations to help guide native seed-based restoration, now I would like to discuss the steps to help ensure the availability of adequate seed supplies of species and sources appropriate for restoration projects and programs. Here are some overall seed-based practices to consider. Early planning. Depending on the plant species, source requirements, quantities desired, and methods of procurement, it can take 3 years or more to acquire the target amount of plant material. A missed window of seed harvesting can result in delays of several years due to seed crop periodicity and unpredictable weather and other factors. It becomes all the more important to determine seed needs for planned projects, e.g. roadside revegetation, pollinator and other wildlife habitat enhancements, invasive weed management, and for emergency restoration needs when there is a high likelihood of unplanned disturbances such as wildfires or flooding. Seed source. A seed zone framework also facilitates seed use planning and contributes to stability and predictability of the commercial market, thereby reducing costs and improving the availability of adapted seed supplies. Appropriate sources for each species are selected using available seed zone maps or related tools, along with knowledge of the species ecology and potential response to climate change. Genetic diversity. Maintaining genetic diversity from seed collection through field increase and planting is crucial for reducing the risk of project failure. This will not only protect genetic resources, but also help improve initial restoration success and provide resiliency against environmental pressures and changing conditions in the future. Climate change and seed source selection. Matching seed sources to climates is made more feasible by the advent of GIS mapping programs that use existing data and climate projections to predict which seed sources will be best adapted to a given planting site, or which planting sites will be most suitable for a given seed source. In North America, the seed lot selection tool and the Climate Smart Restoration tool are becoming widely used for tree and shrub/herbaceous species, respectively. A similar application, Res tool, is available for plant material selection and restoration of tropical dry forests in Colombia. Coordination. Seed procurement and banking programs are likely to be more successful and cost-effective if managers are able to coordinate and prioritize multi-year seed needs in conjunction with other resource disciplines, agencies, and landowners within a seed planning area, such as a seed zone or other biogeographic area. This more integrated and comprehensive approach to seed planning can benefit a wide range of resource needs, protect against overharvesting, and lead to an increased availability of native seed when and where it is most urgently needed for restoring disturbed sites and ecosystems. Other critical factors affecting seed planning and procurement success include supporting infrastructure, such as proper storage facilities, seed processing facilities, and nurseries, as well as seed producers who can operate at a scale appropriate to the production needs of the clients. If seeding has been determined to be a critical step in the restoration process, the following must be addressed from the early stages of planning: species to be used, appropriate seed sources, quantity of seeds, seed procurement methods, budget limitations, timelines, and the risks associated with seeding and how those risks can be mitigated to increase the chance of success. All of these aspects should be carefully considered and outlined in a native seed sourcing and procurement plan that is integrated within the broader restoration plan. Native seed procurement. Several options are available, and decisions require consideration of funding, timelines, and available resources. Some plant materials may be immediately available, such as off-the-shelf purchases or from seed and storage, whereas acquisition of others can require several years depending upon the seed sources selected and time requirements for wildland collection or agricultural seed production. Where available, seed certification and testing standards help to strengthen procurement plans. Some of the common types of procurement tools used for acquiring native seed from collectors and seed producers in the U.S. include the following: blanket purchasing agreements, which involve the issuance of a task order for seed collection or seed production. This occurs via one federal agency to another, from the Bureau of Land Management to the U.S. Forest Service, for instance. Interagency agreements are financial agreements with another federal agency, like the Natural Resource Conservation Service, which administer and operate plant material centers. Assistance agreements are financial agreements with a non-profit private sector entity, like the Institute for Applied Ecology or Botanic Gardens, to collect or produce seed. Indefinite delivery, indefinite quantity contracts, IDIQs, can benefit seed producers because seed delivery orders are funded. Seed is not grown speculatively, and growers are paid upon delivery of seed. IDIQs can simplify seed ordering and purchasing process, and specifications are developed and standardized. Standard contracts. These are used to collect or purchase seed via the private sector, but offer less flexibility to the vendor than an IDIQ. The BLM Indefinite Delivery, Indefinite Quantity Contract, which was initiated in 2019, is designed to make native seed available for more native species and seed transfer zones as per Goal 1 of the National Native Seed Strategy. The contract includes BLM native seed needs by seed transfer zones for 8 U.S. ecoregions for 70 native forbs and 41 grasses, and includes 6 vendors that are pre-approved to bid on seed production delivery orders. Here is a summary of some of the contract goals. Develop seed increase contracts for the BLM focusing on native grass and forb seed. Species selected for seed increase are local genotypes useful in restoration rehabilitation projects. Goal is to also include small and large commercial seed producers, as well as develop unified standards for field production and seed quality. And finally, it's critical to track native seed increase production contracts by state. The contract workflow starts with native seed collection using the BLM Seeds of Success collection protocols. Collections are either single or multiple accessions by seed transfer zone. The seed lots are then sent to the U.S. Forest Service Bend Seed Extractory to be cleaned and tested. The seed is then sent to the Oregon State Seed Certifying Agency to be certified as single or pooled seed lots by seed transfer zone and elevation. Certified lots are then sent to a vendor after delivery order contract award. Seed produced by the vendor is then sent to the BLM Regional Seed Warehouse, where it is tracked as X species from Y seed zone. The seed is then requested by the customer, BLM field personnel for instance, for particular seed transfer zones where restoration projects are planned. The funds from the seed purchases then feed back into funding future seed increase production delivery orders. Seed tracking occurs from collection through field application. Here are some of the delivery order metrics to date that show what is in the hands of the seed producers now, by total number of species and by different types of seed transfer zones. So in closing, successful seedings and seed programs rely on early and thorough planning to identify seed needs. Appropriate sources for each species are selected using available seed zone maps or related tools, along with knowledge of the species ecology and potential response to climate change. The species, sources, and quantity of seed required can then be incorporated into the scheduling and budgeting processes early on, as 2 to 3 years may be required to obtain some seed sources. Seed procurement of appropriate plant materials may include wildland seed collection, as well as increase in agricultural seed fields or nurseries. And finally, seed collection and increase should follow established protocols and guidelines to obtain and maintain maximum genetic diversity and fitness to improve the resistance and resilience of restored communities. I'd like to thank my co-authors, as well as Nancy Shaw, Emeritus Research Botanist for the U.S. Forest Service Rocky Mountain Research Station, and Vicki Erickson, U.S. Forest Service Research Geneticist, for their steadfast work and commitment to native plant research, seed production, and use and restoration. Thank you for your time.